All right, so just kind of going over how to make a graph from details. So this is what we've done in class is creating sine and cosine graphs, really functions, and graphing them from the information that's given. So here's another example. And this refers to the sine tool, and I'll talk a little bit more about what can be confusing about the sine tool, but let's go over this and see what info they've given us. The frequency is 1/4. So that means it completes, it means it needs a quarter of a cycle. It completes a quarter of a cycle in 1 unit. It's kind of a little confusing. It's really the number of cycles per unit that it can complete. What you really need to know is the period is the reciprocal of frequency. So if it completes 1/4 of a cycle per unit, it's going to take 4 units to complete a whole cycle. So it's 4/1, like I said, a reciprocal of frequency. So the period is 4. If the period is 4, that's really all we need here to do this. But if you were trying to come up with the equation, we use the formula B equals 2 pi over the period. That allows us to find b. It allows us to find the coefficient of x in our equation. So that it would be 2 pi over 4 in this case, which we would reduce to pi over 2. The maximum of this graph, so that's the highest y coordinate, that is the y coordinate of a peak or a local maximum is 5 and the minimum is 1. So it's going to go all the way up to here and all the way down to here. So finding the midline is going to be halfway between those. So I could do 5 plus 1 divided by 2, or I could just kind of eyeball it. Oh, it's 2 down from here and 2 up from here will bring me to the same place, which is y equals 3. So y equals 3 is the midline. I'll write it up here, midline. Y equals 3. It looks like it has a y-intercept of 5, so it looks like it's peaking at the y-axis, or the y-intercept is the peak. It also, let's see, we know it has a period of 4. So in 4 units, 1, 2, well, I guess I can go along the bottom here. So in 4 units, it's going to be back up here to a peak. Halfway in between 2 peaks is where it's going to be below. It's going to be at its lowest point. And then halfway between a peak and a valley, it's crossing its axis. So here's an crossing its midline. And then here's another point where it's crossing its midline. So the graph looks like this. And I'm going to go ahead and go a little further with this and say what the equation is. So our amplitude here is, like I said before, it's 2 above and 2 below. So the amplitude is 2. 2 above, 2 below. The midline is 3. So A equals 2. I guess I should really say the absolute value of A, because A could be a negative number. The number, this is the template, y equals A. Sine or cosine, actually in this case, I would use cosine, but we're to use the sine tool. So it brings in a little trickiness to it. Plus 3, this is the midline. Amplitude here is 2, and so this is the part of the equation that kind of spooks or scares some of our students. It's b times x, and b, as I said, b I calculate by doing 2 pi over the period. We know the period's 4, so b is pi over 2. I'm just going to plug that in place here, pi over 2. Now you could graph this in Desmos. You should get a picture that looks very similar to mine. Of course, kind of tricky to make sure you have kind of the right range of values for your x values and your y values, so you're seeing all the graphs, so it's not going ridiculously fast. If you just zoom in and zoom out without controlling your x, your minimum x value, maximum x value, minimum y, and maximum y, you might kind of get a graph that isn't as useful. But anyway, that's not an issue here. Okay, so our equation is up here. Again, this question wasn't asking for it. What it's asking us to do is use the um, use the sign tool. So the sign tool says here, hey, you must first be on the midline, the first point, and then you pick a second point that is at a maximum or a minimum. So we could you could choose either of these points, or you could choose another point, like it's going to cross again here. Any of these points would be okay. And then you need to pick a maximum or a minimum. And these will typically, I think using the K-12 graphing tool, we pretty much stick to integral values for our coordinates, which kind of is nice in a way. So I would click here, and then if I clicked here, it would fill in the rest of the sine wave. All right. Hopefully that addresses any concerns you might have about using the sign tool. By the way, I would use my equation here is not exactly correct, because this would be, if I used sine, it would be actually starting here. So I need to shift this over. If I were to change this to x pi over 2 times, and this gets this, my students right now think it's a little ugly. It's going to get a little bit more ugly when we bring in horizontal shifts. Pi over 2 times x minus 1. So I need to shift a normal plus 3. A normal sine wave. Actually, I need to move it 1 to the left. So it should be x plus 1. Yeah, it gets a little bit tricky. But anyway, if you just use cosine, it's way easier. Because you don't have to worry about the horizontal shift. Y equals 2 cosine pi over 2 x plus 3. That's why cosine's easier. If you pick the appropriate one, you don't have to worry about horizontal shifts, and that just makes life easier. All right. Hope this helps.